Okay, so let's start. This is the third time of me doing this game, which is called Jumping Thieves, and because of some technical glitch, the second time is not recorded, so only this time and the first time. Now let's review what we have now. We have this app class that basically just load a bunch of stuff and create a window and then draws something on the screen, which we have two sprites now. And we have sprite render that actually renders the sprite. And the render logic is here. We pass when the destination code, which is like the size and the position of the sprite we want to render, and also the textual coordinate. Because if we want to render a spreadsheet, then the textual coordinate may not be 0 to 1, but like something else. Like for example, for the second sprite, we render it with textual coordinate from 0 to 0.5, so we have something like that. Our sprite render is really efficient. It may probably make my GPU cry, because for every sprite we have one draw call, and maybe later I will refactor this into instant rendering, but for now I will just leave it this way and just keep things working. Okay, now let's start. The topic today is entity component system. So we will use this amazing library called Entt. It is entity component system library. The reason I want to use this kind of thing is entity component system solve two problems. One is cache locality. In the traditional, like, more object-oriented system, then the cache locality is not good because we have a lot of pointers in directions. And in entity component system, we try to have those kind of array of struct and then struct of arrays, and then try to pack relevant data together. So like we have this struct position, and then we may have an array of that struct position, and we have another array of the velocity struct, and then we have the huge struct that have everything. But since this process is a little bit tedious, so I will use the library. The second advantage of ECS is it makes extensibility very easy. In a static type language like C++, where if we have a struct, the data shape is fixed. On the other hand, if you are familiar with language like JavaScript, then you probably know the idea, like you can just customize an object and put whatever in it. And that's another advantage of the entity component system. So that's why like a lot of games like use this kind of architecture. And let's start. First, I will pull out, we now have an app class which contains everything. I will first pull out a new game class that contains the data relevant to a game. So now we can put a game class here. What's going on here? Oh, should be in here. Do I put it in the wrong image list? Yeah. Now it should be good. Because of some initialization problem, we need to initialize like SDL OpenGL context first, and then we can initialize game. The easy way to do this, not that efficient way, is to just put stuff into a pointer. I'm not saying this is the best way of doing stuff, it's just an easy way of doing stuff. Now we want to put this texture into the game. And whatever stuff that should belong to the game. So game have the texture. Here we don't render any stuff here. We don't load texture here. We load texture in the game. Probably should put this load texture into a separate file, but I will do that later. We can initialize the game at last. Inside the game, we will load texture. Now, the texture here is just like the game only have this one texture, one sprite, but because it's just a demo. Later when we like implement some proper asset management, then we can have more textures and stuff like that. Currently, let's just leave it this way. This should be public. Let's test stuff still compile. What I did. Main CPPP. That's interesting. Oh. Okay, nice. Now let's add two functions. Well, we want to do some physics update for the game. Let's call it fixed update. Fixed update is different from updates for normal update, because for physics we want to have a fixed rate, a fixed update rate. So like for every 10 milliseconds we will do an update. Otherwise there can be some problems. The second is our render function. We need to pass the sprite render into the game. We can also cache the sprite render inside the game object, but I will just leave it like this now. Okay, so inside our initial app, we have this render logic. Now we need to pass sprite render in. Ugh. Now we've kind of done with our refactoring. Everything's still unchanged. If you have any questions, just ask it on the chat. I can see it. So now let's deal with the update. First, we need another variable. Then we can just like for every iteration we add the delta time into the remain times, and should call it remain time, not remain times. Then we see if the remain time is less than 10 milliseconds. We do an update. Now, this way we implemented the fixed time step update. What's going on here? C line is confused, but this should be able to compile, right? Ah. That's not good. So what's going on here? We have game fix update which just do nothing. Ah! Now it's good. Now let's talk about the entity component system. So currently we just hard-coded to draw two sprites on the screen. So instead of hard code that, I will have like the game would actually store the data we want, and then we can draw it. To do that, we need the Entt library. It's not put in. It's good now. And Entt have this concept of a registry, which is basically our game world or game level that contains everything in that game. Oh, that's a wrong spot. It should be here. So let's see what we want for our player. For people who don't know, this Beyond Core library is my own like utility / math / graphics library that I hope one day it become a game engine, but currently it's just some utilities. Our player definitely need a position. Our player also needs velocity. Now we need to draw our player on the screen, so it needs sprite. The sprite have an ID textual coordinates, and it should still have its size. So let's just make size to floats now. And that's it. That's basically our player. At least for now. And now let's initialize those things for Entt. We need a player entity. Which we say is created by the registry. And then we need to create all those components for the player. Let's start from 400. Assign into the player components. Where's the velocity and sprite? for velocity, let's say it moves diagonally for now, and its velocity is like 1 pixel in each dimension for like 10 milliseconds. And it's slow enough so we can like see our player moving. And then for our sprite have texture coordinates. It have probably should initialize those. Not that it matters, but it's just for the best to avoid uninitialized data. Width and height. Yeah, let's just do 50-50 for now. If it compiles, good. And now we want to render this. So instead of this hard-coded stuff, sprite render.render. Now we don't even need to do this at all. Instead, we can. The good thing about this kind of entity component system is we can easily filter out all the entities with the property we want, and then we can just then draw them. So in this case, we need all the entities that have a position and have a sprite. If it doesn't have velocity, for example, it's just stationary, it's a building or something, it doesn't matter, we can still draw them. For each what's the argument order? This texture. Destination. And the third is texture coordinate. For the destination, it's our position this is really ugly naming. Let's maybe change this to data or something. And sprite height. Forgot about the semicolon. And now we should see our player stationary on the screen. Yeah, it's here. If we want to make it larger, now it's larger. So you may ask, what is the advantage of this entity component system? we basically have this kind of complicated thing to implement what we had before. But now let's say we want to add a bunch of monsters, let's say. That's 100 monsters. Ugh. And let's give them some permutation on positions. And some permutation of velocity. Make them smaller than the player, so it's kind of obvious they're different. Also makes the player not that big. So after a few lines of code, we can have a lot of monsters. They are not moving because we haven't implemented the update logic yet. So let's implement that. For this time, I need to filter all the entities have position and have velocities. If it doesn't have a sprite, it doesn't matter. So also change this to data. I hope you can see through this kind of entity component system, it's how easy to implement this kind of stuff. And also the better thing is this kind of architecture is really extensible. Basically, what we call the system is this kind of functions. And if we want to have different system like physics, like AI, we just add those kind of functions and add some data, register it in the registry, and that's it. Unlike in an OOP like architecture, we may have like a central game object class and then have a bunch of components attached to it. Every time we need to change something, we need to change that, and also that's probably a lot of indirections, pointers, dynamic allocations, stuff like that. Okay, so we have this beautiful enemy stuff implemented. Now let's give our player something a little bit different. Make it distinct from everyone else. A player have a speed, and we can control that player. Later we may change every characters have speed, so but now let's just make it this way. Um, oh. So let's say player starts at 1.5 speed. And then we need some special handling for the player. First player do not move at start. And instead we need some like keyboard, mouse and control the player. Currently we have this kind of keyboard handling. Let's add a function to the game class that control the player's move. Player by default is stationary, but player can also move upward, downward, leftward, and rightward. And in here we say if movement is stationary, we set the player's position to 0. It's no longer assigned. I forget what the API called. It's replace. Okay. So it's not assigned. It's replace the old velocity with the new one in place. What is this? Function replace deprecated. No, I'm not using this replace. I'm using the above one. Let's make sure this thing compiles. Probably not, because I didn't handle all the cases and I have warning as error. Yeah. C-line get confused about this. It's actually not deprecated. It have two overload. I'm using the right function, but it think I'm using the deprecated function. For the left, we say the velocity is like moving left times. Oh, we need to get the speed. That's a bit tricky. So our new velocity will become moving left with this speed. And we can copy and paste. Now it should compile. And that's good. Then we can try to add this function into our app so we can actually handle the keyboard moves. If left, we say go left. Left, right, up and down. Consecutive identical cases. It's not identical. I don't know. C-line gets really confused for some reason today. What is this? Can't have a function signature like this in the source file. It cannot be deduced at all. Now we can move our player. We cannot stop it because we only said make it move. So let's change this logic a bit to make the player only move when we have key down. So if we have key up, then we can negate our operations. left, right, up, down. For all the we set it back to stationary. For people who don't know about this force rule, it's a C++ 17 thing to tell the compiler, I want force rule, don't warn against this. So make this explicit. But our whole statement don't have a break. So because we have this kind of attribute now, we can add a warning against all the force rule, and it's useful when writing C switch statement because it's really easy to forget break. Now we can have our player moving, and all the other monsters just moving on their own happy paths. And that's it. That's all the thing I want to implement today. And before I end this stream, the last thing is need to check everything compile fine on the web browser. So it compiles fine. Let's say no, this is my path tree to another project. What's this? Oh, Edge. No. Edge. Yeah, HTTP server. So we set up a server at this generated direction, so we can look at what's the WebAssembly in action, and it looks fine. We can actually using this WebAssembly thing in our browser. That's everything we implement. I want to say today, and we just implement like a lot of objects in motion with an entity component system. And next time I will implement tile map, so we can actually have some background instead of just this purple background. Okay, thank you.